Okie doke. Okay, sorry for the pause there. I turned the sound off before I sneezed. That's what you're hearing. Okay, so we're at problem 60. And what we have is we have a list of consumer price index as a function of year. It says use the consumer price index figures in the table to find the amount that would be charged for using the same amount of electricity that cost $25 in 1995. So all I have to do is take the ratio of the consumer price indices and apply that to the electric cost. So let's write this down. This is number 60. So it says in 1999, what is the cost? What would be the cost, equivalent cost of $225? So what we do is we set the ratio of the consumer price index in 1999. So that's 166.6 to the consumer price index in 1995. So this is 99 to 95, so we do the same thing. What we're trying to do is this is the quantity we're trying to solve for. What is the cost of electricity? And in 1999, and we're comparing that with $225 in 1995. So this is 1999 is the numerator divided by 1995. So this is the consumer price index in 1999, consumer price index in 1995. This is the cost of electricity in 1995. So therefore that's going to be the cost of electricity in 1999. So we cross multiply. So we get that, and then we multiply out the right-hand side. So we get 166.6 multiplied by 225. So we get 37,485. And then we divide both sides by 152.4 to solve for x. So this divided by that is 1. And the answer is $245.96. They rounded up to 246 in the answers, which actually say that to the nearest dollar, so they did ask for that. $246. Now, one way you can shortcut all this is instead of multiplying these things together, you could divide both sides by 152.4 before you multiply this together. Then you just multiply this by this and then divide by that in one step. You wouldn't have to write this number down, and you get the same answer, $246. And really, going back to this original expression, because when you have proportions, you're just dividing a number by a number and a number divided by a number. So the way you can do this is you can just rearrange these numbers. And so what we could do is, if you have a number in the, well, let me step back one thing. Let's say I have something like this, and I want to solve for x. What you can do is if you move this to the other side, what that will do is when you move a number from one side of the equal sign to the other, you just change the sign like that. So instead of writing out -6, -6, you can just say moving it to the other side of the equal sign changes the sign. So if I wanted to move this to the other side, I'd have 0 is equal to x plus 6 minus 10. So moving it from here to there makes it negative. Moving this from there to there makes it negative. Now if it was already negative, then it would become positive. So that's kind of the way you can do solving these linear equations in one variable without having to write stuff out and write that extra step. The same thing kind of applies to division and multiplication, except in this case, instead of moving it to the other side and making it negative when you do addition or subtraction, in multiplication and division like we have here, if you move a number, say this is 225, you want to move it to the other side to solve for x, then you move it from the denominator to the numerator. Or you can move something from the numerator to the denominator. So when you have a multiplication situation and you want to solve for the variable, just move numbers from the numerator to the denominator to the denominator to the numerator. Another way of looking at this is, an equivalent expression for this would be you could just switch the numerator and the denominator. So if I did that, so if I did 152.4, move that to from here to here, and then I switch the other two like that, so I switch the numerator and the denominator. If I cross multiply, I'm going to end up with the same result as if I had initially. So if I move this from the denominator to the numerator, like I do here, these are equivalent expressions, and you get the same answer. So that kind of saves you a step sometimes. That's the way I would do it. Okay, so 63 talks about problems that involve variation. So in an equation standpoint, you get y equals k times x. This is a direct variation. So as x changes, y changes in proportion to it. Or if you took y over x, if you divide both sides by x, you get y over x is k. And these are different values of x and y. So, if I had a y1 and an x1, meaning one condition, then the same ratio of the x and y values would be the same at the second condition. So when you have a direct variation, you basically can set up a proportion to answer the questions. So what it says here, it says if x varies directly as y, which is what that means, it says when x equals 27 when y equals 6, then find x when y equals 2. So it's kind of like you say x1 is equal to 27, and that value of x, y is equal to 6. So then you also have a matching pair at different values of x and y. So this is find x, so we'll call that x. y2 is 2. So I don't know x2, but I do know y2. So what you do is you just set up this proportion, x1 over y1 equals x2 over y2. So x1 is 27, 27 is to 6, as x2, that's what we're trying to solve for, is to y2, which is 2. So it's this to that, this is this, that is to that. And then you just solve it normally, cross multiply. You get 6x is equal to 2 times 27 is 54. Divide both sides by 6. You get x is equal to 9. So 27 is to 6 is 9 is to 2. That also says 27 over 6 is the same as 9 over 2. And you can see that this can be simplified. 27 over 6 is, if you divide both by 3, so divide that by 3 and divide that by 3, you'll get 9 over 2. So simplifying this ratio makes it equal to the other side. Okay, 66. When a varies directly is b squared. So a equals k b squared. That's what that means, directly as b squared instead of as b. What that means is the ratio of a over b squared is going to be the same value, which would mean a1 over b1 squared is equal to a2 over b2 squared. So if you look at the book, we've got an initial pair of A. We'll call that A1, A and B. A1 is 48. B1 is 4. So I've got to be given either A2 or B2. So I read it. This is when A is 48, B is 4. Find A. So that's the one I'm trying to find when B equals 7. So then all I have to do is just plug it into here. So I get 48 divided by 4 squared is equal to x divided by 7 squared. So let's multiply out the squared. So you get 48 over 16 equals x over 49. Cross multiply, you get 16x is equal to 48 times 49. Get 2,352. Divide both sides by 16. And I get 147. So that's actually, yeah, that's the unknown, which is x2, is a2. Okay, so we're going to stop there for this section.